Conditional probability has to do with permutations and combinations. We're going to talk about the difference between those things. But permutations and combinations are where you calculate odds of like winning the lottery, winning raffles, how many possible combinations there are for like a locker combination. You can figure things like that out. You can figure out how many different outfits you can make out of the clothes you have. So, okay. So the first thing we're going to do is we're going to start with tree diagrams. And they're called like a tree diagram because they say they look like a tree, but really it doesn't really look like a tree. It sort of just splits. Yeah, it's sort of like a factor tree, but sideways. No. Okay, so again, extra videos available in the book, which is posted on Canvas. Addition rule was used for dependent events that were mutually exclusive or mutually inclusive. And multiplication rule is used for independent events. Okay, so this is when you multiply, this is when you add and possibly subtract if they're mutually inclusive. For two events on the addition rule, A and B, the probability of selecting one over the other is the probability of the first one plus the probability of the second one minus the overlap. I don't know why that suddenly doesn't work in the right place. There we go. So this is the overlap. Multiplication rule for two independent events, the probability of the first one times the probability of the second one. And again, this is for them both happening. Tree diagrams are another way to show outcomes. So it's snack time, and you have a choice of white milk or chocolate milk, and you have a choice of oatmeal cookies or chocolate chip cookies. How many possible combinations of the two can you have? Yeah. So if you have white milk or chocolate milk, and then you can have chocolate chip or oatmeal, chocolate chip or oatmeal. So you can have white milk and chocolate chip, white and oatmeal, chocolate milk and chocolate chip, or chocolate milk and oatmeal. So you have 4 combinations. No, you have to pick one or the other. You can't have both.
So you can't have.
You can't have like white milk and chocolate milk. You have to have one or the other. And you can't have oatmeal cookies and chocolate chip cookies. You have to have one or the other. So if you have that with those 2 items, white milk, chocolate milk, or oatmeal cookies, chocolate chip cookies, there are 4 possible combinations that can be made. Tree diagrams help you figure out the number of possible combinations. And they're good for small amounts of things because you can see all of the possible combinations. But if you start getting into large possibilities, like there are like 30 flavors of ice cream, and you can pick 3 of them to make a cone or whatever, and you start trying to diagram all that out, you'd have 30, and then each of one of those 30 would have another 30, and then each one of those 30 would have another 30, and it would get really big, right? So tree diagrams are only really useful for like small numbers of items. Okay. Now, oops, wrong way. If we toss a coin 2 times, what is the probability of getting 2 heads? So we're going to do 2 tosses. We have toss 1 and toss 2. Okay. So you start, guys. I can get heads or I can get tails. Okay. On the second toss, I can get heads or I can get tails. And if I get tails the first time, on the second toss I can get heads or I can get tails. So there's 4 possibilities that can happen. Heads and heads, heads then tails, tails then heads, or tails then tails. And I want to know what is the probability of getting 2 heads. 2 heads only occurs once, right? Out of 4 possibilities. So my probability is 1 out of 4. forgot to record this. Okay, so red, white, brown, red, white, brown. Do you guys get the idea? Do I need to keep doing this?
Yes.
I got a yes. He's just being mean. Huh, I wrote those out of order just to confuse you. Okay, so each time he can pull out a red, a white, and a brown. Okay, so when he does that, there's 3 possibilities for each one of these original possibilities. So he has 4 plus 6 is 10, 18 original possibilities, 18 first socks options, and then times 3. So out of all of these, there are a total of 54 possible patterns. Okay, and we want to know what is the probability he pulls out a red and then a white. Red then white, red then white, red then white, red then white. 4 times he can pull out a red and then a white. So our probability is 4 out of 54, which is 2 out of 27. So every 27 times he does this, twice, he'll pull out a red and then a white. The 54, 4, because we want to know about pulling out a red and then pulling out a white. So here's red, then white, red, then white, red, then white, red, then white. So that happens 4 times. Brown, yeah. So there's 18 of these across the top, and then each one of them gives you 3 choices. So 18 times 3. Okay. So when it's repeating like this, you don't have to draw all of them. Like I didn't have to draw all these, but just to make sure you know that each one of these is also going to have 3 so that you can count up your total amounts. And I didn't draw the brown ones because I want to know starting with red. So be sure to draw, guys, be sure to draw the ones for the starting. You don't have to draw all the ones for the ones that you don't care about the first thing. Does that make sense? If the first sock is not replaced. If your first sock is not replaced, it becomes out of 53 for the second. So it changes, it changes the outcome for the probability of a white. Okay. All right, here we go. Here's with percents. You can also put percents on the tree diagrams. Each of these is a percent. 54%, 42, 58, 48, 52, 46. Okay, we want to know. In a survey, baseball fans were asked who they want to win the National League playoffs. So we got 54% for the Phillies and 46% for the Giants. And then for the American League playoffs, we have the Rangers and the Yankees. We want to know. Okay. All right, we want to know the percentage of the fans for each of the matchups. So Phillies, Rangers, Phillies, Yankees, Giants, Rangers, Giants, Yankees, okay? So probability, I'm going to call these P, R, Y, G, okay? So we want to know probability of P and R. Phillies and Rangers. We have 54% on the Phillies, 42% on the Rangers. When I multiply those together, I get 0.2268. So there's a 22.68% probability that you would like that combination. Or we have the Phillies and the Yankees, which is 54% and 58%, which multiplies to 3132. So a 31.32% chance that you would want that combination. Probability of the Giants and the Rangers, 46% times 48%. gives me 0.2208, so 22.8% chance that you would want that combination if you were asked a random person on the street. And then we have the Giants and the Yankees. Okay. Gives me that combination, which is 0.2392 or 23.92%. And then it says, do these add up to 100? Well, add them up. So yes, they do add up to 100%.